Hello, and welcome to this lesson on integration by parts. Today, we'll tackle the integration of a function involving the product of an exponential and a sine function. Our goal is to find the integral of e to the power of x times sine of bx using integration by parts applied twice. Let's briefly review the integration by parts formula. The formula is given by the integral of u dv equals uv minus the integral of v du. To solve our integral, we'll need to choose appropriate expressions for u and dv. For our first application of integration by parts, let's choose u equals e to the power of x and dv equals sine of bx dx. Differential u is equal to a times e to the power of x dx, and integrating dv, we get v is equal to negative 1 over b times cosine of bx. Substituting into the integration by parts formula, we have the integral of e to the power of x times sin of bx dx equals u times v minus the integral of v du. Our result is negative e to the power of x over b times cosine of bx minus the integral of negative ae to the power of x over b times cosine of bx dx. Let's proceed with the second application of integration by parts to solve the remaining integral. This time, let's choose u equals e to the power of x and dv equals negative ae to the power of x over b cosine of bx dx. Differential u remains the same as previously, which is a times e to the power of x dx, and integrating dv gives us v equals negative sin of bx over b. Substituting again into the integration by parts formula, we have the integral of negative ae to the power of x over b times cos of bx dx equals u times v minus the integral of v du. This results in a times e to the power of x over b squared times sin of bx minus a squared times the integral of e to the power of x sin of bx over b squared dx. Now let's substitute our last result back into our first equation. Combining the results, we have negative e to the power of x over b times cosine of bx plus a times e to the power of x over b squared times sine of bx minus a squared times the integral of e to the power of x sine of bx over b squared dx. We've now arrived at an integral on both sides of the equation. To solve for the original integral, we can add the integral term on the right side of the equation to both sides and divide everything by the coefficient of the integral to solve for the original integral. Introducing I as our definite integral, we have I equals 1 over 1 plus a squared over b squared times the sum of negative e to the power of x over b times cosine of bx plus a times e to the power of x over b squared times sine of bx.